Review. And how many electrons are in gold? How about Chris? Okay. Jake? 79, very good. So every element has the same number of electrons and protons. This is going to be helpful to us today when we look at bonding, specifically ionic compounds. And how many neutrons are in gold? Hannah? 118. Does everybody understand how she got that?
Add you subtract the protons from mass.
Very good. It's a subtraction problem. Excellent. What is the pseudo noble gas formation for zinc? That is, what noble gas is zinc behaving like? It's for zinc as an element. You see that it has the argon, then it goes to the 4s, and then it goes to the 3d. Now if we look at argon, argon should be in the third period, which it is. So you see helium, neon, argon. So argon is the third full period. And then they go on to the fourth period, which is 4s. So the 4s would be the electrons in the outermost shell. Jake?
It also would be krypton.
Which element, which noble gas is it behaving like?
So would it be neon? 'Cause like,
Close. No.
is it krypton?
Starts with an H.
Helium.
Helium, yeah. So that's why they're calling it a pseudo noble gas configuration, because it's not going to 8, it's going to 2. Well, helium is considered to be a noble gas. It falls into that group. You see helium there in the back of the textbook?
Just the exception. Yeah.
Right. So it's kind of an exception.
How does it drop down? Because like zinc is in the third level.
Right, but the third falls back into the argon period. So it's basically reinforcing that lower energy level to support what's on the above fourth period. So it's kind of like if you wanted to build another floor on this building, you have to reinforce the lower levels before you could put another one on top. That's kind of what's happening, because 10 electrons, that's quite a few electrons there in the 3D. All of them are filled there.
So where does neon go?
A neon is not, they don't have enough electrons for neon. You'd need 6 more to get to neon. To fill the 4p shell, you need 6 to fill in there. They don't have that. So but they're calling it pseudo because it's behaving like helium. And once again, it is pseudo because the octet is what the periodic table, that's the strength of the periodic table is the octet. The predictability of the periodic table is the octet. Because there are 7 periods that we rely on. You're going to name all of the halogen group, all the oxygen group, and the carbon with the ide. It is the nonmetal, changes its name to ide. This is called the crisscross method, where you take the charge and it becomes the subscript. So you notice here, you don't need to put a 1 here. It's not Ca1O1. That's just too much to write, Garrett. Write this down. Now, if you want to write the 1, you can, but most people are going to be wondering why you're doing more work than you need to. Right? Helium and fluorine, these are our 2 ions, calcium and fluorine. When they come together, they're going to form a compound. Now, what's nice about this, all compounds have 0 charge. So when we're talking about balancing compounds, the goal is to get them to where the charge is 0. So if I have a 2 positive here and I have a 1 negative here, what do I need to have here? I need 2. I need 2 of the fluorines. 2 negative 1s will equal 2 positive, give me 0.
Oh, so you gotta match them.
Right. So the crisscross here would say Ca1, because the 1 is going to go here, and 2 here. But the whole point for you to understand has to do with balancing of the charges. What you see here, the charges are what's going to be balanced, because all compounds have 0 charge. They behave like elements. That's why they're stable. Water is very stable because...
Does there not need to be like a 1?
No.
Okay.
There's going to be a 2. It's going to be CaF2. This is your correct response here.
Okay.
This would be wrong. So compounds are stable. They mimic elements because they are balanced in their charge. Because elements, if you remember, have the same number of electrons as protons. So gold is very stable. We're doing this element ball project. It's from the American Association of Chemistry Teachers. First year I've done this, doing something new. Kind of a review. Are in gold. How many electrons are in gold? 79. Who said that? Good job, Simon. All elements have the same number of protons and electrons. That's going to lead us into bonding today. How many neutrons are in gold? Take the mass minus the proton, gives you the neutron. Neutrons control typically the radioactive decay of the element. Because if you change them, they can become unstable. Okay. Sounds close. I don't have it memorized in my brain, but that sounds right. The point is that when you look at isotopes, like we looked at yesterday, the carbon-12 was stable, carbon-13 was stable, carbon-14 is the one that's radioactive, and it's just a trace amount of your body. So the neutrons determine the death of the element. Balloons that you use. Hope. What happens to the helium in the balloons that you use? Can we capture it? Where? No, I mean, can we capture it from the atmosphere? Where does it go? It goes to outer space. That's one of the problems with using helium. It goes, because it's so light, it just travels to the upper atmosphere, and then it just eventually goes into outer space.
So that's why balloons do that? I bet you
Well, balloons would not be light enough to make it into outer space, but once the helium got out of the balloon, it does.
So the balloon just goes up there, flies around, and
It deflates, falls down, but the actual helium that was inside the balloon escapes to the outer atmosphere. Now, we can mine helium out of the ground. It's found in compounds, which is what we typically do today. But we don't get it out of the atmosphere. Oxygen will change its name from oxygen to oxide because it is a main group element. So the charges here are the same. Magnesium is found in the second group. Oxygen is found in the 16th group. The oxygen group come together, cancel out their charges. 2 positive, 2 negative equals 0. And then you get magnesium oxide. Kaylee? 79 protons in gold. How many electrons are in gold? Vance? Yes. Elements have an equal number of protons and electrons. That's what makes them stable. Now we're going to see that today when we talk about balancing compounds. How many neutrons are in gold? Raise your hand. 118. Now we learned yesterday that the neutrons are associated with death, right? Because carbon 12 has 6 neutrons, carbon 13 has 7, carbon 14 has 8, and that's the one that's radioactive. Even though it's trace, it's just a very small amount. Too small to put on a balance and measure. That's why I feel older than the Earth. Talked about that yesterday. If I were to die and they were to radio date me, they couldn't determine the age of the Earth by my atoms. Because I'm older than the Earth. I feel older than the Earth. I can feel it. It feels good. It feels good to be older than the Earth, right, TT? I do. It feels good. It makes me feel, you know, like mature. I'm older than the Earth. It's good. I've been around longer than the Earth. Billy? I've been around longer than the Earth.
Okay.
Helium is a pseudo noble gas because it does not follow the octet rule. So when you flip back here on the periodic table, you see helium in the first period in the noble gas group. It's a pseudo noble gas. It doesn't have 8 electrons around it. But you'll see that the transition metals like zinc right here is behaving like helium, the pseudo noble gas. Now zinc will desire to lose those 2 electrons, and when it does, it gains a 2 positive charge. Group noble gas, correction, main group nonmetals. So you'll see right here that would be the halogen, the oxygen, and the nitrogen group here. So calcium chloride, you'll see that calcium has 2 positive. We have to add another 1 negative. And that gives us 2 negative and 2 positive. This number right here is called a subscript. Now, if you look here, how many oxygens you see? No, that's the charge. It's 2 negative. So you have 1. So you don't want 2 there. You have 2 lithiums here, right? Yep. And then you have to put the number of lithiums there, though. You have to put a 2 right here. I know, but you have to tell me how many you have there. So it's 2. You don't need to put the 1 there because it's assumed. So it's Li2O. Now go ahead and name it for us.
That is not right. You cannot do that.
Bet you get it.
Am I right so far?
I can't say anything. Let me know when you're done.
Oh. Wow. Okay. So. I don't know. 2.
Is that your final answer?
I think it's H2. Is it H2?
You can talk to your friends. You can phone a friend.
Okay. Because you don't need to put it since there's only 1. So is it H2O?
Do you think it's H2O?
I would guess.
Is that your final answer?
I mean, yeah.
It is correct. Nice job.
The group 1 and 2 metals are the most reactive metals on the periodic table. For example, potassium and magnesium, group 1 and 2 elements, respectively form K positive and K positive. Potassium positive and magnesium squared positive ions. Some group 13 atoms also form ions. The ions formed by metal atoms in groups 1, 2, and 13 are summarized in table 7.2, period.
Now the goal of chemistry is to predict the future. That's how you make money. It's kind of like the lottery. They've changed the odds to win. They've actually decreased the odds of winning the lottery. So if you can predict the future, you can make money. If you cannot predict the future, you're going to lose money. That's how chemists make money. So up here on the periodic table, you'll notice that group 1, these elements tend to lose one electron. That gives them a positive charge. And with that information, we can predict future behaviors or future products when you react the reactants. So this is something you're going to want to write down if you don't have this written down. Now I gave this to you yesterday with the atomic structure Lewis dot diagram. You can see that it's associated with the main group. The main group is what we use in chemistry to predict future behavior of reactions.
Are we doing a lab today?
We are doing something similar to a lab. 14 is the carbon family, 15 is the nitrogen family, 16 is the oxygen family, and 17 is what?
Boring. Boring.
No.
Boring.
Raise your hand.
Or fluorine.
No. No.
Boring.
They're called the halogen family. Yeah, the last group is pretty significant because it has such a strong desire to gain electrons. Chlorine is used in killing bacteria, and fluorine is used in toothpaste to help strengthen your teeth. It plays a role in your bone development as well. Positive, yes, and sometimes negative. If you get too much fluorine is really bad for you.
Electrons. Forming two positive ions, however, is also possible for d electrons to be lost. Thus, transition metals also commonly form ions with 3 positive or greater, depending on the number of d electrons in the electron.
It's affecting the United States right now. There's something called a, there's something called a,
I saw a biblical
it's the bomb cyclone.
I saw something. It was like it's a biblical reference or something.
Okay, whatever. The point is they do not know, Maddie, the reason why the upper winds are coming down the way they are. They're unsure why that's happening. Well, when we figure it out, we can then predict the future better. So you can make money predicting the future. If you've been following the lottery, they changed the lottery predictions. That is, they've made it more difficult to win. So they decreased the odds of winning. Now the thinking is more people will play because of it, because you'll get into that billion range to win. People are like, oh, I can win $1 billion for $1. Right. So up here, Maddie, you can see that the first group wants to lose one electron, and because of this behavior, we can then predict how it's going to behave when it reacts with other elements. So chemistry is about predicting behaviors.